Now let's assign the stereochemistry to the 3 chiral carbons in this particular molecule right here. We have hydrogen atoms that are present in this molecule that are all on the dashes, which is fantastic, which means that all of these carbon atoms, we're looking at all of them from the right direction. Step 2, we won't have to rotate anything. Let's start by assigning priority to this particular carbon right here. We know that the hydrogen is going to be the low priority group for this carbon. The other things attached to this carbon are a carbon, and a carbon. So that's a three-way tie. We have to look at what is attached to each of these 3 carbons. This is a carbon with 3 hydrogens. This is a carbon with 2 hydrogens and 1 carbon. This is a carbon with 1 hydrogen and 2 carbons. So we have a hydrogen, hydrogen, hydrogen versus a carbon, hydrogen, hydrogen versus a carbon, carbon, hydrogen. Let's look at that again. We're looking at this carbon versus this carbon versus this carbon. This carbon has 3 hydrogen. This carbon has 1 carbon, 1 hydrogen, and 1 carbon. And this carbon has 2 hydrogens and 1 carbon. So we're comparing these 3 sets of atoms. We're looking for the highest atomic number. First of all, the highest atomic number is carbon, and we have 2 groups that have carbons present. So in that situation, we are looking at the one that has the most carbons. This has 2 carbons, this has only 1 carbon. So this is the highest priority carbon. This guy right here is our high priority. This one right here is number 2, and this one right here is number 3. To assign stereochemistry, we pretend like that 4th low priority group is not there. 1 to 2 to 3, that is the beginning of an R. So let's clear some of this out. We're going to write in that this guy is an R, and then let's move on to the next chiral carbon. We're now looking at this guy right here. That one has a hydrogen, which is going to be number 4. It has a methyl group, and then it has 2 parts of the ring. So we know that this methyl group is going to be low priority because it's got 3 hydrogens on it, whereas the other 2 carbons have more interesting things than that. So this carbon right here is a hydrogen, carbon, carbon. So that's a hydrogen, carbon, carbon. And I'm going to erase this. Now we're comparing to this guy right here. That's a hydrogen, carbon, carbon. So we have a tie again, hydrogen, carbon, carbon, which means we need to continue moving away from the chiral carbon. So moving on down to these 2, what do these have? And again, we're moving away, so we're not going to go backwards. This one is a hydrogen, hydrogen, carbon. Hydrogen, hydrogen, carbon. This guy right here, also hydrogen, hydrogen, carbon. So this is another tie, hydrogen, hydrogen, carbon. That means we need to keep going. Now when we move down to the next layer, they connect. We have now connected. And so what this means is that when we go this way around the ring versus when we go this way around the ring, we're never able to break the tie. This is because the left way around the ring and the right way around the ring are identical to each other. And when these 2 directions are identical to each other, we know that that means that, in fact, this carbon here is not even chiral at all. Now, you may have caught that right away. You may have seen the symmetry of this and realized that that carbon was not chiral. But if you missed it because you were so focused on looking for R and S, and the wedge and the dash kind of tricks us as well, you would be able to determine it, even if you missed it. In your efforts to determine if this was R versus S, you would find that you can't classify it, you can't break the tie, and that means that it's not chiral. So here's our last one for us to classify. Our hydrogen is number 4. We know that methyl is going to be number 3, and we're now comparing this carbon to this carbon. And we've seen enough examples right now that maybe you can tell that since this carbon up top, this carbon right here, is branched, it has more carbons attached than the one down here, which means that it is going to be higher priority. So this is going to be our number 1, this is going to be our number 2. When we ignore number 4 and we look from 1 to 2 to 3, 1 to 2 to 3, that is an S. This particular type of a molecule is called a Miso compound. This is a special type of molecule. A Miso compound is a molecule that has chiral carbons but is overall achiral because it has a plane of symmetry. So a Miso compound is a molecule with chiral carbons but also has a plane of symmetry. And that plane of symmetry makes the molecule achiral, even though it contains chiral centers within it. For this molecule, the plane of symmetry is right down here through the middle. You might be saying, wait a minute, what about this guy right there? That is not symmetrical. Remember that this hydrogen is actually tucked behind this methyl group. We just can't draw it that way. So we have a plane of symmetry that goes right through that achiral carbon, making this molecule Miso. It has chiral centers, but the molecule itself is achiral.